Assalamu alaikum, my dear students. I hope all of you are fine and doing well. So in our today's lesson, we will discuss about the solubility and solute-solvent interaction. For this, you must guys know about the solubility. Mainly solubility is going to be happen when we add just solute in the solvent. So the amount of solute that just dissolved in 100 gram of solvent at standard temperature and pressure, this is mainly known as the solubility of the substances. Now in this we have a look on the solute solvent interaction, that when we add a solute in the solvent, for example here we have a solvent for water and we just add up the sugar in it. What type of interaction is created between this solvent and the solute particles, that it just get dissolved in it. For this solubility and solute solvent interaction, we guys must know that there is a guiding rule for solubility, which is like, dissolve, like. It simple means that we have two types of substances. The one is polar and the other one is non-polar. The polar substances just get dissolved in the polar and the non-polar get dissolved in non-polar, and both polar and non-polar are immiscible into each other. This is a simple rule of like, dissolve, like. The next we have the dissolving of ionic compounds in the polar solutions. When we have a polar solutions, they are basically having poles, or they are polarizable ionic compounds that are made up of ions. For example, a simple ionic compound we have NaCl. When ionic compounds get dissolved in the polar solutions, then their solubility is high, as the ionic compounds just changes into the positive and the negative charge ions. On the other hand, the positive part of the ion is attracted by the negative part of the solvent, and the negative part of the ion is surrounded by the positive part of the solvent molecules. In this way, the interactions will be created between the positive and the negative ions, and the solubility is high. Let's have a look on this picture. We have sodium chloride crystals in which negatively charged chloride ions, and these are the positively charged ions. So the positive charge, that is sodium, it is surrounded by the negative part of the water molecule, and the negative part of the salt is attracted by the positive side of the water molecule. So this is the simple solubility of the ionic compounds in polar solutions. They get dissolved into each other, or they are miscible into each other. Next, we have dissolving ionic compounds in non-polar solvents. So we have a lot of non-polar solvents like benzene. We have we have gasoline. These are mainly non-polar solvents. Along with the simple example from our houses, it is oil. Oil is also non-polar in nature, or non-polar substance. So when the ionic compounds are added into it, it do not get dissolved or do not interact with the non-polar solvents, because ionic compounds are mainly polar in nature and they do not get dissolved into the non-polar substances. After this, we have the liquid, solute, and solvents. The liquid, solute, and solvent means when both the solute and solvents are in liquid state. For example, here we have the water is a solvent And the solute particles we have alcohols or methanol or ethanol C5 2H5OH. This is the ethanol. Now the ethanol will created the bonding with the solvent, that is water molecule, because both are having hydrogen bonding and they get dissolved into each other, and the interactions will be created between them. And when the interactions will be created between them, in turn the solubility will be increases. How, what type of interactions will be created? Let's have a look on its structure. So when we draw a simple structure of interaction of ethanol, the structure of ethanol is like this: C2H5, and then we have oxygen and hydrogen. Oxygen is having partial negative charge and hydrogen is having partial positive charge. So this is the one molecule of ethanol, and then we have the water molecule in which the oxygen is having partial negative charge and the two hydrogens are along with the oxygen having partial positive charge. So there is an interaction created between the methanol and water molecule. This interaction we called as hydrogen bonding. As both are of similar nature, then they get dissolved into each other. On the other hand, when we have another example of two liquids in which we have benzene, whose formula is C6H6, and we have another liquid oil, they both get dissolved. What is the reason? Because they have the same nature, both are non-polar liquids. When their nature is same, so they get dissolved into each other. But when we take two immiscible liquids, like if we take oil plus water, then we can see the two different layers of the substances. The first one layer will be oil, and then we have the water. It's mean both have different nature. When the different is or the nature is different, it's mean they do not get dissolved into each other. In turn, they are known as immiscible. And when they are immiscible, it's mean one is of polar nature and the other is of non-polar nature. So this is a simple topic that we have discussed today. I hope you guys understand, and if you have any queries, you may ask me about that in the comment section. And the next topic that we will discuss, it is the effect of temperature and pressure on solubility. For that time, you guys have a good day and keep learning in a better way. Allah Hafiz.